Hi, my name is Gopi Kumar. I'm a program manager in the Algorithms and Data Science team within the Microsoft Data Group. We're going to be talking about building intelligent applications using SQL Server R services. With me, I have Hang Zhang from our team.
Hi, my name is Han Zhang. I'm a senior data scientist in the same group as Gopi. Today, we are really excited to be here to introduce you how you can use the very excellent Microsoft R service to build your intelligent apps.
Recently, we have seen a trend with intelligent applications. Corporations are redefining their applications to be more intelligent. What actually do we mean by intelligent application? And let's contrast it from traditional applications. So in traditional applications, your program logic is hard-coded using expert logic and some intuitions. In contrast to that, intelligent applications leverage not only the expert logic, but also they leverage data from the enterprise and also data sets from outside the enterprise like public data sets, social data feeds, and they use it to make predictions and take automated actions on this dynamically. Now let's hear from Hang about some examples of intelligent applications.
Intelligent applications are almost everywhere, probably more universal than you have ever thought. Every time when you shop online, there is a recommendation model running in the backend recommending related items to you. Even every time when you step into an elevator, there is a predictive maintenance model running in the backend to predict when this elevator will fail. Now, let's Gopi to introduce you an end-to-end process to how you can build an intelligent application.
Here is a generic process for building intelligent applications. This is a process that we have come up within our data science team that helps you kind of go through the process in a very systematic manner. So we've broken down these into 5 steps: the ingest step, the exploration step, the featureization, the modeling, and the consumption. So these are the 5 steps that you kind of go through. And remember that this is a very iterative process. So you'll see that you end up going back and forth between some of these processes as you go through your experimentation. So let's take the first step is you bring in data from various data sources. These data sources could be within the corporation, within enterprise databases, enterprise data warehouses, or it could be external to the company, like public data sets, or even data from social media that you can bring in order to create your intelligent applications. So once you bring in your data, you need to kind of get a deeper understanding of what this data is telling you. So this is where you do some data exploration, where you get really deep into the data and then gain some insights. So once you gain insights, you will get some kind of an idea like what are some of the main attributes of the data that will help build a predictive model. So this is where the featureization step comes in. So you create data attributes or also called features, which will let you create a good predictive algorithm. I'll hand it off to Hang to kind of talk about the last 2 steps, the modeling and the consumption part.
So after you have built a very insightful feature, you think that you are ready to move forward with model. So the next step you need to do is to build a predictive model based on the feature you built. So after the model building can be iterative because you might need to use some validation set to understand whether your model is good after you put in production. So if you're not satisfied with the model, you might go back to the feature step to build more features, or you might even need to tune your models or change to train different models. After you are satisfied with your model, you can move forward to the next step to consume your model, to operationalize the model so that this model can be consumed by your intelligent app. So today, in this end-to-end walkthrough, we are going to use the real data to show you how you can build intelligent app using the NYC taxi data, which is publicly available.
Let's go into each of the steps in detail and also talk about how we can execute those steps using the SQL Server R services. So the first step, as we remembered, was the ingestion of the data. So this is where you bring in data into the SQL Server, And here you can use all the standard tools that are available with SQL Server 2016, like the bulk copy, or SQL Server integration services, Polybase, or Azure Data Factory. And we can specifically leverage features available in SQL Server 2016, like in-memory column store indexes for parallel loads. As data scientists, we really like these features because they allow us to kind of bring in data into the database really quickly, and we can bring in like large amount of data in parallel.
So after your data is in the SQL Server, the next step is to explore the data so that you can have some insights to the data. The data exploration step might include such as summarizing data using purely SQL, such as group by, something like that. Or you can even clean the data if you know that some data is not right. For example, if the pickup location of NYC taxi data is 0 or less than a certain value, because you know the geolocation of NYC, right? So you can also do some data validation in R. Say you can write some R functions which can be embedded in the store procedure to do the data validation. So the R has also a very rich library of data exploration and visualization. You can borrow that capability into your SQL application to do the data exploration visualization, which is more powerful than the visualization power of SQL Server.
So once you have gleaned the data and you understand the data patterns, you are now ready to start thinking about how you can build a model. One of the inputs into the models are the data features. So you create different attributes from your existing data, and this process is called data featureization. So here you can use the features of SQL Server 2016, where you can build these as SQL functions in order to create new features. Alternatively, in case you can't do it using SQL, you can also use functions defined within R and embed these R scripts within the SQL store procedure to create the new features. So you'll notice that as you go through these experimentations, SQL Server functions may be more efficient and more suitable in some cases, whereas R may be more suitable in some other cases. So you get to pick and choose the most efficient way so you can improve your productivity.
Once you are satisfied with your feature set, you can move forward to build your predictive models in R. R has a big, rich library of predictive models such as logistic regression, random forest, GBM. You can directly embed your R codes in store procedure to build the model. This store procedure will be called by SQL query. After your model is ready, you can call a simple function predict. This is a function in R to make predictions on the new observation you want to build predictions on. You can also call a performance function to evaluate your model on an unknown validation set, which is not involved in the model training. Then, after that, you can persist your model in a record in the database.
So once you have persisted the model within the database, now it is available to be called from any client applications. And these applications could be written in any language. And the consumption model is like pretty simple. So all you do is you open a connection to the database and invoke the store procedure, passing in all the necessary parameters. And the output from the store procedure will be whatever you're trying to predict. So it could be a score, or it could be a specific prediction on like what products to recommend. So the client application, it's a relatively straightforward integration to go and consume this model pretty easily. This is in contrast with like a traditional approaches where to get from the model to consumption, it's a pretty long step involving like software development and deploying of software. So with this model, you have a very simple way in which you can operationalize your models so they can be called from any client applications.
Now I'm going to walk you through an end-to-end demo using NYC text data to show you how you can build your intelligent app using SQL Server 2016 with R service. The problem we're going to tackle today is predict whether a trip is tipped or not. The data we're going to use today is the NYC text data 2016. It has 48 gigabytes unzipped. The first step we're going to show you is to how you can ingest your data into SQL Server. The next step will be how you can explore the data and visualize the data in SQL Server using R services. After that, how you can do feature engineering, how you can build a model, and how you can persist the model are also covered. In the end, we are going to show you how you can consume your model in an application.
So now let's look at how we can build this intelligent application end-to-end. So the first step is ingest. So we are, as we mentioned, we are importing about 48 gig of data into the database. That takes a few minutes. So we're going to skip that particular step. We have already imported the data into the database. So the step after the ingestion is exploration. So you can start the exploration in SQL first using just plain SQL, do some summarization and aggregation. So I'm going to run the very first query here. So as you see that this query returned pretty fast because we are using the SQL Server column store indexes where we can calculate aggregates. Even though there are millions of rows, we can calculate these indexes, these aggregations pretty quickly. So as you can see that you get an idea for each different passenger counts, how much is the tip and what's the average tip percentage. You see that on an average, the tip is around 11%. So not a lot of variations between passenger count, except for passenger count 3 and 4, you see that the tip is about 9% and 8%, a little bit lower than the average that you see for the other passenger counts. So you can run other aggregations. One other step that we do during this exploration is also look for whether your data is clean. And for this, you do data quality analysis to see if the pickup and the drop-off latitude, longitude is has some bad values. So let's just execute this query. So as you see that there are only 9 rows which have some kind of a suspect latitude and longitude. So for most part, the data quality is good. So we can choose to drop these 9 rows from our analysis, from our later analysis. So for more advanced visualization, we can switch into R, where R comes with the library of exploration and visualization function. So let's move into RStudio and look at some summarization and exploration of the data. So here we open a connection to the database and set the compute context to run completely in SQL Server. So which means no data is moved into the client machine. So all the queries that are executed within R will actually execute on the server side within SQL Server. So here we see that there is a query that we are trying to run. So we take, let's say, 5% of the data, and so we select various rows from this particular table. And we can plot histograms from this particular data. So let's do a histogram by tip amount and payment type. So I'm executing this R program. Here you see that the histogram by different payment types. So you see that the tip amounts for cash is like almost 0 all the time. And you see that for credit card, there's a pretty even level of tip. See, from anywhere from $1 to like about $10 tip. And there are a few other types that are not very common. So most of our focus is on credit card type because it looks like for cash, the tip is not properly reported, as so most of the time it shows up as 0. So in our analysis, so this is one of the insights that we gain from the data by looking at this particular histogram diagram. So next, let's look at a few plots. There is a plot called cube plots. So we have already kind of run the cubes, and R provides something called a level plot, which says, okay, can we tell like for different pickup latitude and longitude, what kind of tip amounts are we seeing? What's the tip distribution? So I'm going to run this level plot. So you can see that here you can see the shade. So all the dark pink are the ones with like 0 tip, And you see that the lighter the pink, I think you have some tip amount, $1 or $2. And then the one in the cyan has a tip of almost $25. And this is, we are plotting across the latitude and longitude, like just to get an idea. Are there like regions within New York City where, based on the pickup point, is the tip amount likely to be higher? So this is something that allows you to get that level of insight. SQL Server R services also allows you to use some open source R libraries to do more advanced mapping functionality. So here next we are going to try to plot the pickup points on a map. So here we retrieve, so we have a function that actually executes within the R, within the SQL Server, which opens up a map, and then it plots all the points that are there within the database. So you don't need to retrieve the point list back into the client. So you pass this function all the way into the server and execute this thing using the rxexec function. So let's try to execute the rxexec function to plot the map. So now the map, representative of the map has been returned back from the server. So we will try to plot it on R. So here you see the map of New York and all the points that shows the various pickup points. So as you can see that within Manhattan, the Midtown Manhattan, probably there's a lot of trips that are originating from the Midtown Manhattan area, and very few trips, so relatively fewer trips that are in the other parts of New York City. So this is kind of an example of the kind of plots that you can do. You are again leveraging the strength of R in doing visualization, but then executing these R functions within the database so that the data never leaves the source of data. We can also run these R functions as stored procedures. So I'll go back and show within SQL Server Management Studio. So here we can build a histogram. So similar to what we did in R, on the R Studio, we can actually embed this particular code. Here you see that you're executing execute external script language equal to R, and then calling Rx histogram. The output of this will be a binary that is passed back to the client. So now any client that can call the store procedure can actually get the power of R, and you are actually getting the actual final representation of the histogram that you can render it on these clients. So any dashboard like Power BI or Excel, so anything can call the store procedure and render this image. So these are some of the ways in which you can explore the data. So now that you have explored the data, you found different ways to explore it, you get some insights. The next step is to do feature engineering. So let's move into feature engineering. So there are a couple of ways you can do feature engineering. One is you can actually execute it within R. R provides functionality. So here I've built a function. So I'm going to create a new feature which takes the pickup latitude, longitude, and the drop off latitude, longitude, and finds a distance between that. People have published different formulas. So we happen to use this formula called the Haversine formula, which executes a bunch of functions and computes the real distance between the pickup point and the drop-off point. So once we define this function, we actually tell, we use this function called SQL Rx data step and compute this distance passing these attributes, pickup longitude, pickup latitude, drop-off longitude, and the drop-off latitude. So what this Rx data step is doing is it's doing a data transformation and adding this extra attribute into that particular data set. So this is one way of doing it. You can also do it as a pure SQL query. So here what we do is we've defined functions within SQL. So I move into SQL Server Management Studio. So we have functions defined to compute this distance. So the same function that you saw within R, you can actually implement it in SQL, and So we are essentially doing the same thing here. And then the feature itself can be generated through another function, a table value function, which will call this fn calculate distance. So what this is doing is, this is doing a select and then adding all the attributes that are needed to build the model. So these are all the features that we that came from the original data. And then we add this extra feature called the function calculate distance, and we call it the direct distance. So these are all the various features that we'll use to build our model. So I can also move into RStudio, and then we can actually call these the same function within R also.
After you are satisfied with the feature set you have built, you can move forward to the next step, build the predicting model. In this demo, we are using the Rx logic to predict whether a trip is tipped or not. The formula is that we are using the fare amount, passenger count, trip distance, trip time in seconds, and direct distance. Here, the direct distance is a feature we built using the Rx data step function we just showed. After the model is built, you can call the summary function to get insight to the model, such as what parameters are more important than others. For example, from the summary output, you can see that the fare amount, passenger count, trip distance, and trip time in seconds, they are all significant to the model. After your model is built, you can call the model to predict the output on the validation data. In this way, you can know how good your model performs on the holdout data set. After you have the prediction on the validation data, you can call the Rx ROC curve to get the performance matrix on the validation data. Here, the output of this ROC curve function is the AUC ROC curve. From this value, you can see that the AUC equals 0.98. That's pretty good. So if you are pretty satisfied with the model performance, you can move forward to persist your model. We call it model operationalization. Here, the way to operationalize the model is to convert your model into a binary and save this binary string as a record in the database. You can also do the model training and model operationalization in store procedure of SQL Server. Here, we use the Rx logic, the same function, to train the model. And after the model is trained, we use the serialization function to convert this model into a binary and store this binary as a record in the database. After the model is persisted, you can develop a store procedure in SQL Server to consume this model. After the model is converted as an R object by the deserialize function, you can call the Rx predict function to make predictions. Now let me show you how you can consume this store procedure in SQL Server store procedure to do this. You just pass the parameters to the store procedure and run it. This SQL query will output the probability that this trip will be tipped. Now let me show you how you can consume this store procedure in an application, the Excel. Let me switch to Excel. Here in Excel, you only need to pass the variables you need to know about this trip into the store procedure. Here we can show you how you can wrap this up in the Excel application. You can see that you only need to pass the variables you get from the cells in Excel to the store procedure. And then if you click refresh, you should be able to see the probability that the trip is tipped, returned from this model. You can see that for this trip, with 97% probability, this trip will be tipped. That is how an application here, we use the Excel as an example, how to call the store procedure to make predictions.
We have seen how you can build an intelligent application using Microsoft SQL Server R services. We have looked at a systematic and iterative process to go about building this application. As you can see that leveraging the relative strength of SQL and R services allows you to be productive. You also seen that it is very easy to operationalize your models and consume it from client application written in any language. We invite you to check out the tutorial that we have published on MSDN. A link to the same is shown on the slide. Using this tutorial, you can imagine your very own intelligent application and deploy it within your enterprise.
Hopefully, with Microsoft R service in SQL Server 2016, you can build your intelligent apps more easily. You can be more productive than before. Thank you for using Microsoft R service in SQL Server 2016.